Greetings. Today we are going to learn about supermesh analysis. Supermesh analysis. When we use this supermesh analysis, definitely we are going to use for a mesh analysis. So when a current source is connected between two meshes. So if we see this circuit, the question is that we have to find the current I flowing through 1 ohm resistor. So if we see the circuit, we have two meshes, and through this mesh I1 current is flowing. Through this mesh, I2 current is flowing. If you see these two meshes, in between these two meshes, there's a current source is connected. Current source is connected in between these two meshes. This is when we use a super mesh analysis. So what you do to apply super mesh analysis? Whenever we have a circuit like this, we have to remove the current source. So quickly I will read the definition. When a current source is connected between two meshes, we have mesh 1, mesh 2, we remove the branch having the current source. Okay, I have removed the branch having the current source. The remaining loop is known as super mesh. So what is this? This is I have removed the current source, whatever left out, this is our super mesh. So this is the super mesh. Super mesh. This is a super mesh. Now what I have to do? I have to apply KVL in the super mesh. So in the mesh 1, what was the current flowing? I1. The mesh 2, I2. And 2 amp we don't want now. I2. So now I am going to apply KVL. So I'll start from the voltage source, negative terminal. I'll start. I'm moving like this. I'm moving from here. There's a rise in potential, so I'll take it as plus. Then here through the 5 ohm resistor, I1 current is flowing minus 5 I1. It's a potential drop. Why is a potential drop? So this end of the resistor is plus, this is minus. All these resistors are same because current direction, you see, current will flow from higher potential to lower potential. So plus, minus. Now through 2 ohm resistor, I2 is flowing. So again it's a potential drop to I2. Then through 1 ohm resistor, I2 is flowing. So it is I2 equals 0. And now I will simplify it. I'll write minus 5I1 minus 3I2 equals minus 10. Sorry, equals minus 10. So we got our first equation. This is our first equation we got. Now with one equation and two variables, we can't solve it. This is where you have to care while applying super mesh analysis. See here, this is our current source. 2 amps current source. I'll draw it here. This 2 amps current source. 2 amps current source. Now if we see the direction of I2 also flowing in the same direction, similar to 2 amps. But Y1 direction is opposite to it. I1. This is I1. Now the second equation, how do I write? See, second equation I'll write it as I2 minus I1. Second equation, I2, okay, I2 minus I1 equals, something is just like slipping off. I2 minus I1 equals 2. Right. See, I2 and I2 amps are in the same direction. I1 is in the opposite direction. So I wrote I2 minus I1 equal to 2 amps. This is the important thing you have to care about while applying super mesh analysis. Now we will simplify the equations. So what I'll first I'll write I1. Okay, no, I'm not writing. I'll just write it as I'll write the equation once more. Minus, now we'll solve it. Minus 5I1 minus 3I2 equals minus 10. Right? Minus I1 plus plus I2 equals what? 2. Now we have to cross multiply, then only we can simplify this equation. So I will take this minus 5 and multiply the second equation. I will take minus 1 and multiply the first equation. This is I1, okay? It's I1. If I multiply with minus 1, it will be 5I1 plus 3I2 equals 10. Now with minus 1, I will multiply, minus 5, I'll multiply the second equation. So it will be 5I1 plus, no, we will get minus because it's minus. Minus 5I2 equals minus 10. Right. Now if we simplify this, what we get? We are going to subtract 5I1, this is 0I1, this will get cancelled. 3I2 minus 3 minus 3I2, no, 3 minus minus of 5, you will get 8I2. So 8I2 equals what we will get? 20. Right. 10 minus 10. It will be, you will get it as 20. Use the calculator to solve this question. That will be easy. So I will get easily I2. What is I2? I2 equals 20 upon 8. Right. What's answer? 2.5 amps. So the current, what is I2? The I2 is the same current which is equal to I that is flowing through this 1 ohm resistor. So this is equal to 2.5 amps. 2.5 amps. So we have done it with Supermesh analysis. So we will see some more problems. I'll be updating Supermesh analysis, Supernode analysis, and many more network problems. So if you like the video, please hit the like button. Please share the video with your friends and please do subscribe. Thank you. Thanks for watching.